Alright, there's nothing I like better than a few good k-value questions. So here we are doing a couple of graphs and relations questions from previous exams. And what we'll do is we'll start with some fairly accessible ones and then get into some really tricky ones. Alright, so what we've got here is a coordinate point 2, 20 on this hyperbola. Okay. Now what we don't know is the k-value. Okay, so this is probably as simple as it gets, and you can tell it's question 3 from the module. All we're going to do is substitute this point into the function, okay, and we get the k-value. So let's stick it in there. So this is the x value and this is the y value here. So when y is 20, k on 2, okay, and then we can just solve this, okay, which involves multiplying both sides by 2. The k value is 40. Okay, getting a little harder. Alright, so question 7 from the module. Back in 08 there was 9 questions in this module, so 1 out of 2 people couldn't do this question. So the graph above shows the relationship between y and x squared. The relationship between y and x is, okay, so what's happened is they've applied a good way of thinking about this is they've applied a transformation here to y and x, which is basically straightened out a parabola, okay, or had the effect of straightening out a parabola. So what we're going to do is basically find or treat this like a linear equation, which is we're going to find the equation of it. Now note that it goes through the origin, which is 0, 0. Okay, so the equation is y equals mx plus c for any linear. Because this goes through the origin, we're going to have no plus c. Okay, it's just going to be the gradient multiplied by x. Now what we can do is note that as the x values increase by 1, the y values increase as the x values increase by 4, the y values increase by 1. So that's a change in 1 for the y values over a change in x of 4. So those of you know rise over run, okay, or whatever, but just go change in y values over change in x values, which is 1 over 4. So y equals 1 on 4x. But this isn't a relationship between x and y. This is a relationship between x squared and y. So what we're going to do is replace this x variable here with y equals 1 on 4x squared. And here it is here. Alright, so not much work involved in a question like that, but not many students could do it right that year. Alright, so really similar question here. We get a graph of y versus 1 on x, okay, and you might ask, well, why is it being straightened out? Okay, well, what's happened is they've got a y equals, or a relationship between x and y, which is a hyperbola, and what they do is they use a transformation to straighten out the y equals x graph. Okay, so let's work out the equation for the straight line, y equals mx plus c, and we'll note that again this question goes through the origin again, 0, 0. Okay, so again no plus c value. Okay, so what we're going to do is work out the gradient. Okay, so the change in y values is 5, the change in x values is 2. Okay, so 5 on 2x, but again this isn't a relationship between y and x, it's a relationship between y and 1 on x. So we're going to go 5 on 2 times not x but times 1 on x. That's y equals 5 on 2x, and there it is there. Alright, so a more applied question here, because we're now, instead of just a bog standard graph, we've got a case study. Heat intensity of a fire H is recorded at different distances from the fire. It's plotted against 1 on d squared. Okay, so again the original would have been a portion of a truncus, and what they did is applied a transformation to straighten out the truncus. Alright, so what we're going to do is again note that, oh my god, they all go through the origin. Okay, so we're going to get the equation of this straight line. Is y equals mx plus c, goes through the origin, no plus c. Let's work out the gradient. Okay, change in y values is 25.7 over the change in x values 0.44. Okay, and we're multiplying that not by x though, so I'm jumping a step here. We're multiplying it by 1 on d squared, and it's not y, it's h. Alright, so can't see any of that there, so let's multiply it out. 25.7 over 0.44 d squared. Again, can't see that there anywhere. Okay, and the trick is we've got to put 0.44 into 25.7, and if we do that on the calculator, 0.44, 58.4, which is this value here. Okay, so h equals that, into that goes 58.4 times over d squared, so that's why this is the correct answer. Alright, again a bit more of an applied version of a question here, and this is a good question, this one, and the state did well on it, 62%. Okay, now what we got is a graph showing braking distance in meters of a car at different speed. In k's an hour, the coordinates of the point on the graph are shown. Okay, so what we're expecting is if a car's doing 75 k's an hour, it's going to take 45 meters to stop. Okay, now what we're doing is we're trying to predict the braking distance when the speed is 60 k's an hour. Okay, given this formula. So let's just see if we can predict it off the graph. It's going to be somewhere there, you know, bit under 30 maybe even on the knocker, I don't know. So all I know is it's going to be one of these three values here. 24 is just a little bit too low. I don't think it can be that. I certainly don't think it can be 48. So it's going to be one of these values here. And that's why I think the state kind of performed a little better in this, is that you could make an educated guess and you had a 1 in 3 chance of getting it right. Alright, so for this one here, what we've got is a unknown k value. Okay, and what we're going to do is work it out. So we're going to sub this value in. Okay, now braking distance is 45 meters equals k times the speed squared. Now let's not square that value. Let's square that value. Okay, because this axis here is speed, not speed squared. Okay, so it's going to be 75 squared. And k is 45 on 75 squared. When you jump over to do that on your calculator, you'll find that it is 1 on 125. Okay, so do that on the calculator and you'll see that it's this value here. So now the formula is B, braking distance is 1 on 125 speed squared. Alright, so speed is 60, so we're going to go B equals 1 on 125 multiplied by 60, and 1/125th of 60 is, what happened there? 1 over 125 times 60. That's why I'm not getting it right, because I've got to square it, of course. .8. There you are. So State did very well on this question. I wonder why it was. Maybe you just got it. But yeah. Alright, question 7. This is hard. Quarter of the State got this one. The graph above shows a relationship between y and x cubed. The graph that shows the same relationship is one of these. Alright. So for this one here, again, let's just take the same approach we've been using with these straight lines here, which is working out the equation. Y equals mx plus c. There's no y-intercept, so it's just mx. What we're going to do is work out the change in y values, which is 1, over the change in x values, which is 3. 1 on 3, and it's not x, it's x. Okay, so one of these has the same relationship. So what you want to do is sub the coordinate points given in each of these into this equation here, and one of them will satisfy it. Okay, so you just need to go methodically. Now I just know, I've done this question a few times over the years from experience, that the answer is actually this one. And so I'll show you that if we sub it in, basically we've got 1/3 multiplied by x cubed. The x value is 1 there, okay, and we're cubing that. Well, those of you who know or remember your indices from a few years back will know that 1 times 1 times 1 is just 1, so the answer to this is 1/3, okay, and that means that y is 1/3, and if you sub in x you also get 1/3, which makes it true. And you'll find that for all of the other options, when you test them out, they're all false. Okay, the left side and the right side turn out differently. Alright, so this brings us to last year, this question here, and it was a bruiser. Okay, so what we know here is we've got a point on this line here. Okay, now it's on this graph here, so they haven't given us the k value, they haven't told us what the graph is. It's going to be either an x squared or an x cubed graph, because squared graphs in quadrant 1, they're parabolas, so it just looks like that, and cube graphs look like that, so it kind of looks like a part of a parabola as well. So we don't know what that value is there. Okay, so we can't find a k value, we don't know what the n value is, so what can we do? Well, this is where I sort of go down here and I go, oh, okay, we've got a boatload of straight line graphs. Okay, so why don't I find the equation of each of these straight line graphs here, and then use this test point from the question to see which one makes it true, which is basically the same as this question here, except it's in reverse. In reverse, straight line here, test equation. Okay, so what we'll do is, let's see if we can vet out any options. Okay, so another graph that represents this relationship between y and x, well, it certainly can't be this one. Okay, why not? Because this is a relationship between y and x, and this is a relationship between y and x. Okay, and we know that that can't be the case. It's got to be, you know, a different. It's either going to be squared or cubed. Okay, so we know that it's either that, or that. Okay, now again, I know from experience that the answer to this one is D, is E rather. Okay, so I know that when I find the equation of this, which is what I'll do, okay, goes through the origin, so y equals a rise of 3, okay, or a change in y values of 3, change in x values of 2, so it's 3 on 2 x cubed. Okay, so that equation there, let's use 212 as a test point. So 12 equals 3 on 2 multiplied by 8. Okay, and 12 equals 3 8s are 24 on 2, and 12 equals 12. 24 divided by 2 is 12, so that's true. Okay, so the answer is E, but I couldn't see that. I basically had to eliminate this one, and this one by finding the equation of each of them and then running that test point. It's a fairly involved question, am I right? That might take you 5-10 minutes, and even it would take a couple of minutes just to sort of work out what approach you were going to run with it, I think, as well. Okay, so there's some really a good variation of k-value questions, some really hard ones and some more accessible ones.